All right, for this video, we're going to go ahead and go through how to graph exponential functions. So here is what the equation of an exponential function looks like. We have y equals some number to an exponent of x. I wrote b there because we call that the base. So y equals some number to the x, we call that the base. We also call it the rate of change, or the growth rate. And it can be different. So y equals 2 to the x, y equals 3 to the x, y equals 4 to the x, etc. And so we have some important information that we can see from a parent graph, and a parent graph is just like the most simple example. So if you plug 1 into a parent graph, if you plug 0 into a parent graph, you get 1 as the result because b to the 0 power is 1. If you plug 1 into the parent graph, b to the 1 is b. And then these graphs are always going to have a horizontal asymptote. So y equals 0 would be the most basic version. But obviously, as you do different transformations to the graph, you could have a different horizontal asymptote. So I'm going to go ahead and graph this. We will draw a graph that's y equals 2 to the x. So we have a horizontal asymptote at 0. And then I have the point 0, 1, and then 1, and the base would be 2, so over 1 up 2. And again, since we have an asymptote, we've learned about asymptotes last unit, so now we need to make sure that the graph follows the asymptote, like that. All right, so let's go ahead and do some examples and just go through this so that we know how to work with them. So first, before we find anything else, we're always going to have to know what the base is. And the reason that we want to know the base is because we want to make sure we don't confuse it with a transformation. So this particular function has a base of 3. And then aside from the base of 3, it's been reflected over the x-axis. It has been shifted to the left 2. So you'll see that the inside of the function, it doesn't have parentheses this time because it's just everything would be written up as an exponent. But if you want to put parentheses around the exponent, you can. That's the part that tells you how much it shifts to the left or to the right. And then it has shifted down 1. So first thing I'm going to do is make sure that I always know what the horizontal asymptote is. And it's the number on the end. So that should remind you a little bit of the rational unit because the number on the end of the rational unit also told us a horizontal asymptote. The only difference here is that we just have a horizontal, we don't have a vertical. So horizontal asymptote, y equals -1. We're always going to want to make sure that we know what that is and that we draw that in first. And then what I'm going to go ahead and do is I'm going to graph this equation. So -3 to the x plus 2 with a -1 on the end. And I'm just going to go ahead and make my window normal again. All right, and when I look at the table, this transformation was left 2. So when I look at the table, I'm going to look for -2, and then I'm going to do a couple of points around there. And the reason I'm going to look for that point is because that point is usually the easiest to graph. So -2 has the y-coordinate -2. And then -1 is -4. And so what I do is when I connect these points, I make sure that I follow it towards the asymptote. And you want to follow it towards the asymptote in a way that makes sense. So like don't go like this because that's weird. Like that doesn't fit. We want to do it the other way. So I'm going to take the points, follow it towards the asymptote like that. And then in the other direction, it just grows really fast. So this one is going to grow down very, very quickly. All right, so we have all sorts of different things we want to find just like normal. So the domain, this graph goes left forever. It also goes to the right forever. So it's -infinity to +infinity. The range, if we go from down to up, it goes down forever, and then on the up swing, it stops at -1. So negative infinity up to -1. If we put a little stick figure in there, he would be right here. And so this is an x value of negative infinity. This would be an x value of positive infinity because it's a right arrow. And he is walking downhill, so he is decreasing only. So for increasing, I'm going to put none. For decreasing, I'm going to put negative infinity to positive infinity. As far as maxes and mins, mountaintops or valleys, there are none for this graph. And then I want to go ahead and find X and Y intercepts. So for this one, I'm not going to have an X intercept, and that's because that asymptote keeps the curve from crossing the X axis. So for that, I'm just going to say none. But for the Y intercept, I can go ahead and plug in 0, and I get -10. Actually, I guess I could say continuous. So is the graph continuous? The answer is yes. So if you need to trace this, you can trace it with your finger, so it is continuous. And then for our end behavior, as we follow the graph to the left forever, we can see that it's getting closer and closer to that asymptote of -1. As we go to the right forever, we can see that the graph is just going down. All right, and I think that's all the things we want to look for. Okay, so let's look at the next problem. Again, I'm going to look at that horizontal asymptote. This one's at 4. And then I also want to know what the base is and write down what all those transformations are. So the base is 4. The base is whatever number has the exponent. So since the base is 4, that means that the 4 is not included in any of the transformations. So we have a vertical stretch of 2, right 2, and up 4. Okay, so I'm going to go ahead and graph this. 2 times 4 to the x minus 2 plus 4. Now sometimes you'll see it written like this where it has like a dot there for whatever number was stretched or compressed multiplied by the base, but sometimes you could see it as 2 parentheses 4 to the x minus 2. And I just want you guys to know those are the same thing. So when I graph it, it's not going to graph 2 different things, it's going to graph just one graph. So those are exactly the same. It's taking a long time because it's graphing the same thing twice. Okay, so again, this shifted to the right too. So when I look at the graph, I'm going to look for +2, which is 6. So I have the point +2, 6, and then 312 would be kind of hard to graph. That's off the screen, so I'll do 1, 4.5. Over 1, up 4.5. So again, we're going to connect the points so that they get closer to the asymptote, and then the other ones go far away. Okay, so domain, this graph goes left forever and it goes right forever. Range, this graph does not go down forever, it only goes down to 4, but it goes up always. For increasing and decreasing, I'll go ahead and draw my little stick figure. So here's negative infinity because that's a left arrow. Here's positive infinity for a right arrow. And he is walking up a very steep hill, so that's increasing. So we will say he is increasing from negative infinity to infinity, and he is never decreasing. Again, we don't have a max or a min. There's no mountaintops or valleys in these graphs. Again, we actually don't have an x-intercept because the asymptote is keeping the graph away from the x-axis, so we're going to put none. but I can go ahead and find the y-intercept. I'll just plug in 0, 4.125. So 0, 4.125. Okay. Is the graph continuous? Yes. And then for our end behavior, we're going to say as x goes to the left, when I look at the left side of the graph, I can see that it's getting closer and closer and closer to that asymptote, which is a y value of 4. So as we go left, y goes to 4. As we look to the right, y goes up forever, so y goes to positive infinity.